Welcome to aminacademy.com. In electrical engineering, let us do some solving problem regarding capacitors. Example, a voltage V is applied to the inner sphere of a spherical capacitor, whereas the outer sphere is earth. The inner sphere has a radius of A and the outer is B. If B is fixed and A may be varied, prove that the maximum stress in the electric cannot be reduced below the value of 4V by B. Here, the spherical capacitor have inner and outer sphere. Inner sphere radius is A, outer sphere radius is B. Inner radius equal to A, outer radius equal to B. Here, outer is earth, inner is varied. Now, we know that for spherical capacitor, voltage V equal Q over 4 pi epsilon 0 epsilon r 1 over A minus 1 over B. Now, the value of electric intensity at any radius x. Electric intensity. Electric intensity at any radius x between two plates which is given by E equal Q over 4 pi epsilon 0 epsilon r x square. From that we can get it Q equal 4 pi, cross multiplying 4 pi epsilon 0 epsilon r x square E. Now the substitute this Q value here, that will be 1 here, this is 2. Now substitute Q in 1, we get, look at here, we are get V equal Q, substitute this. So we have V equal 4 pi epsilon 0 epsilon r x squared E over 4 pi epsilon 0 epsilon r into 1 over A minus 1 over B. Now, from that we can get it E equal by cross multiplying E equal V over V over V over 1 over A minus 1 over B into x square, because this 4 pi, this epsilons are cut. Now, for maximum value of E, for maximum value of E occurs as the surface of inner sphere. Occurs at surface of inner sphere. so that we can get it. Then that is when x equal to a. Substitute x equal to a, we can get a maximum E. Therefore, d by d differentiating d by dA of 1 over a over 1 minus 1 over b a square, because you are substituting here x as a, that is a square. So, or you can get it d by dA of now multiplying a square inside, which is a square over a square is a minus a square by b. Like that, here this a square is multiplied with here, that is a square by a, that is a square over b is here, equal to 0. Differentiating dA over a is 1 minus 2b, 1 minus 2a by b, 2a over b equal to 0, which gives further a equal to b over 2. A equal to b over 2. Then substitute this a here. That is a equal to b by 2. Therefore, E substituting a values equal to v over 1 over a minus a is b by 2. Therefore, 1 over bx square is there already given. Therefore, we can get it E max, E maximum at p over 1 over a minus 1 over b, x is a, that is a square. Now substituting this value a equal to b by 2, which gives that means we have to get it b equal to 2a, b equal to 2a, that is 1 over a minus b equal to 2a by 1 over 2a a square, which is equal v over a square by a is a minus a square by 2a is a by 2, which is equal a in terms of b. You can substitute because we need in terms of b here, because we have to prove in terms of b here. Look at here, we have to prove this 4v by b. Therefore, E max equal v over a is, for maximum a is b by 2, 1 over b by 2 minus 1 over b, and a square is b square by 4. Now which is equal V minus 2 over B, 1 over B squared by 4, which is equal V 2 over B minus 1 over B is 1 over B into B squared by 4, which gives 4V by B. 4V by B. Therefore, E max for U over B. Hence, we proved. Next question. Look at here. A parallel plate capacitor has three dielectrics which relative permittivity of 5.5, 2.2 and 1.5 respectively. The area of each plate is 100 square centimeters and thickness of each dielectric 1 mm. Calculate the stored energy in the capacitor when a potential difference is 5 kilovolt is applied across the composite capacitor so formed. Also calculate the potential gradient developed in each dielectric of the capacitor. Look at this setup here. Three dielectrics is one by one it fitted, and it's called composite capacitor having plate area is each plate area is 100 centimeters square and thickness of dielectrics is 1 mm. Now capacitor C is total capacitor in this composite is epsilon 0 A, that is plate area, over D1 by epsilon R1 relative permittivity of first one, D2 over epsilon R2, D3 over epsilon R3. Now we are substituting the values. Epsilon 0 is approximate 8.854 into 10 raised to 10 raised to minus 12 into plate area is 100 mm squared is meter squared is 10 power minus centimeter squared is there, so meter squared is 10 power minus 4 over. Then each is thickness of D1 is 1 mm, that is 10 power 3 over 5.5 first dielectric. So relative permittivity of first dielectric is 5.5. Second thickness 10 power minus 3, as second dielectric is 2.2 and third dielectric is 1.5. So this we calculate further. Look at here. C equal 8.854 into 100 into 10 power minus 4, that is minus 14 here, because here 100 is 10 power 2, here 10 power minus 4 is 10 power minus 2, here 10 power minus 12, totally 10 power minus 14 over this calculation is 10 power minus 3 into 1 over 5.5, 1 over 2.2, 1 over 1.5 together is 0.30. So which gives 292 into 10 power to microfarad. that is minus 10, that is 292 10 power minus 12 comes. This is called a microfarad. This is the total capacitance of. Calculate the total capacitance we found. Next one, calculate the stored energy. Now Q equal to CV. We have C is 292 into 10 power minus 12, that is microfarad. The voltage is 5 kilowatt, that is 5000 watts, which is equal 146 into 10 power minus 8 coulomb. Minus is minus 8 coulombs. Here, therefore, after that we are getting D equal to Q by E, that is coulombs per area. D is coulombs per area, that is coulombs per centimeter square we calculate, that is equal to Q over A equal 146 into 10 power minus 8 divided by area is 100 into 10 power minus 4. 100 centimeter square is 100 into 10 power minus 4 meter square, which gives 146 into 10 power minus 6 coulombs per meter square. That is flux. Coulombs per meter square is this much. Now we have to calculate the potential gradient developed in each dielectric. Potential gradient. Potential gradient of each dielectrics. First, potential gradient of first one is G1 is equal to E1, which is equal D over epsilon 0 epsilon r, which is equal 146 into 10 power 146 and 10 power it's minus 8, not minus 6, it's minus 8, minus 8 over D is, sorry, it's minus 6 is correct. 10 power minus 6. Then minus 6 over 8.854 into 10 power minus 12 into dielectric epsilon or relative dielectric is 5.5. Relative permittivity of the first one. So by calculation, which gives 3 into 10 power 6 volt per meter. Similarly, G2 is D by same E2 is G2 is E2, which is equal D by epsilon 0 epsilon R2 equal same 146 into 10 power minus 6 over 8.854 into 10 power minus 12 Second dielectric is having relative permittivity is relative permittivity of the second one is 2.2 here. 2.2, which gives the second one G2 is 7.5 10 power of 6 volt per meter. Volt per meter. Similarly, G3 is d by epsilon 0 epsilon R3 equal 146 into 10 power minus 6 over 8.854 into 10 power minus 12 into third dielectric having value of 1.5 equal 11 into 10 power 6 volts per meter. These are answers we have done. Please subscribe our YouTube channel.